Okay, today we are going to see about an sensor calibration. Okay, so all the measuring instruments which has to prove themselves their ability to measure reliability and accuracy. Okay, so for this, what you have to do it of actually the results of measurements has to be compared with the highest standard. It is either to be the national or international standard. So the procedure the involved here, this is to be termed as an calibration. Okay. So calibration, what we are defining, it is a set of operations that establish the relationship between the values that are indicated by the measuring instrument and the corresponding known value of a measurement. Okay. Whereas it is the experimental determination of the transfer function of a sensor or actuator. Okay. So the calibration of a measuring instrument means so it introducing an accurately known sample value of the variable that is to be measured over here, and then it will be observed. Then observing the system's response. Okay, so then the measuring instrument is checked and adjusted until its scales read the introduced accurately known sample of the variable. Okay, so it should be further noted that an instrument is calibrated at one place and it is good to use at some other place. Care should be taken that the instrument is used at a place where the environment has the same conditions as that of the places where the instrument was calibrated to ensure that the instrument gives correct reading. So typically needed when the transfer function is not known or not, the device must be operated tolerance below those specified by the manufacturer. So for example, if you're using a thermistor with 5% of tolerance on a full scale from 0 to 100 degrees Celsius, to measure temperature with accuracy of say plus or minus 0.5 degrees Celsius. The only way this can be done is by first establishing the transfer function of the sensor. Okay. So we'll have a two methods. One method is to be if you have known the transfer function. So the first thing it is to determine the slope and the crossing point from two known stimuli. So for example, let me say the two temperatures. Okay. And if the transfer function is linear, then we have to measure the output. So if it is known transfer function, the first thing is it is to determine the slope and the crossing point. If the transfer function is linear, it is we have to measure the output. So calculate the slope and the crossing point in B is equivalent to AT plus B. Okay. Suppose if the function is more complex, so we have to make over here by V is equivalent to AT plus BT2 plus BT3 plus BT4. It is the A, B, C which are to be calculated over here. So apart from that, we have to choose the points effectively. If linear, use the points close to the range. If not linear, we have to use equally spaced points around the locations of highest correlation. So this is when we know the transfer function. The next thing, if unknown transfer function is there, that is the method 2. So it is used, that is we have to measure the output Ri at as many input values Gi as Ki is to be the practical value. And apart from that, it has to be used the entire span. So among that, we have to calculate a best linear period, the least squares. Okay. If the curve is not linear, then we have to use the polynomial system. That is, we may use piecewise linear segments if the number of points is to be large. Okay. So calibration is sometimes an operational requirement. This for the case of an thermocouple pressure sensor. And usually the calibration data is supplied by the manufacturers and the procedures must be included with the design documents also. So errors due to calibration must be evaluated and specified. Okay. So when we are saying about an calibration procedure, actually we'll have often two different types, namely primary calibration and secondary calibration. Okay. So what we'll be doing in the case of an primary. So primary, if the instrument is calibrated against a primary standard. Okay. So then it is to be named as a primary calibration. So similarly, if we are using of an secondary for further classification for other devices, so it will give a lesser accuracy. So this type of instruments where we'll be using over at Abina, it is used in general laboratory practice as well as in the case of an industry. And secondary calibrations can be further classifying into two different types. One to be the direct calibration and other one to be the indirect calibration. So the direct calibration is general of the same order of accuracy. Okay, so the instruments which are calibrated directly, it will be named as an direct calibration. Whereas in the case of an indirect, the procedure is based on the equivalence of two different devices adopting some same similarity concept over here. Okay, so these are all about the sensor calibration. So the calibration is just a set of operations in order to establish the relation